this is a process. And so that's really what I want everyone to think about, is that what we're trying to do is begin to build a logical relationship between the projects so that we're not just in silos. And so I am very thankful for all of these folks for stepping in and stepping up and onward.
Onward. All right, we will start with Matt. Let me get you stuff queued up here.
So I'm going to introduce Matt.
Yes, please.
Matt and I hail from the same smokescape.
Both blacked out.
Both blacked out. Were you evacuated? Yeah.
No.
Both evacuated.
No, I wasn't evacuated.
Oh, you weren't evacuated? Okay, I was evacuated. So we are wearing our climate crisis badges. But at any rate, Matt did something very, very brave, which is at the edge of the flexibility market, in the world that Matt comes from and OpenEEmeter comes from, there's almost a division, and that I think that sometimes that in putting OpenEEmeter and EM2 into the Linux Foundation, we've had a challenge to figure out how to actually begin to give visibility into your view of the universe with the view of the universe of the operators. And sometimes it must seem like you come from totally different worlds, but it's my belief that what you have accomplished in a relatively short period of time is begun to lay the market framework for flexibility. And so that was the reason why I kept reaching out and really wanted you all to be part of this community, because creating new markets is not for the faint of heart. And I think you've done a stupendous job at laying that foundation. And now, it's like kind of what I'm hoping is that we can skip it over here to Europe, and that you all, who maybe haven't thought about some of the things that Matt's going to talk about, can actually begin to see the world in a new way.
Thank you. So I think actually the good news is that for the first time ever, we are actually talking to folks on the procurement side and the energy market side of the world, and we're making flexibility behind the meter into something that actually makes sense in that paradigm. And that's really the overarching goal, and the challenge has been everyone will stipulate that energy efficiency is really important, but when it comes to actually integrating efficiency or demand response, or frankly storage or EVs or anything behind the meter into the grid, really on par with traditional supply side resources, it's been a real mixed bag, frankly, and it's really challenging to do. And we think there are a bunch of reasons for that, but the very fundamental, most baseline reason for that is that we haven't agreed on what the product is, which makes trading in a market really, I wouldn't even say hard, impossible. If you don't know what you're transacting in, you can't value it. And you can't, if you're in the grid side, you can't rely on this flexibility solution actually being there if you can't measure what the output is, and if you don't have good data and actuarial performance data on what to expect. So that's really our overarching vision. Around the world, as we decarbonize, and more decarbonization is the goal, which has been pretty amazing to see in the US, even with our current president and administration. Decarbonization is everywhere. I was just in Texas and I had taken out all my decarb slides, and that was the only thing anybody was talking about. But as a function of this move towards clean energy, we have all sorts of animals showing up. It's not just the duck curve anymore, all over the world, being driven by solar, wind, other grid resources. So as the grid operators in this room know, this is havoc, right? Like we have instability in the grid in California right now. It's not a theoretical problem, it's a real problem, and it's very expensive. And this is what carbon looks like in California. It's an hourly problem. It's locational. It actually varies a whole lot depending on where you are in the grid. This is actually the average for the whole grid. So the easiest term of what we're trying to do is use the green and less of the red, basically. We are overgenning renewables in the middle of the day, and then we're paying other states to take them off our hands and then running nat gas all night, which is great to generate a lot of solar, but we got to use it more efficiently. And it's an enormous problem. This is an example of what we're seeing on the grid. We'll have $2,000 megawatt hours one day. A couple days later, we'll have negative $300 megawatt hours in the same hour. It's kind of mayhem, being driven primarily by solar And we have fun things like cloudy days and things like that that create a lot of havoc when you're on the grid, when you're actually trying to make plans and forecast the grid, when you start seeing these high levels of renewables. And the problem is just immense, right? We want, the grid solutions are great, but what we're seeing actually is that renewables and particularly solar in many of these markets are accelerating so quickly that the gap, the flexibility problem is actually getting worse, not better, with everything we are aware of. All the solar, all the storage, all the EVs, all the demand response we can account for. We're seeing that, but it's not, all that's great, but the solar's peeling away, right? And there's a gap that continues to grow. And so, our belief is that one of the most valuable and plentiful resources and also least cost resources that has to be brought into the equation is not just how we supply energy, but how really buildings and end uses consume energy and aligning demand and what we call demand flexibility with the supply side and making it work on equal terms. So we're helping, for example, how do we solve for non-wires alternatives, which is replacing power plants. So in this case, we're helping PG&E replace a gas turbine in the middle of Oakland. If you want to do that, actually a big part of this is grid scale storage. You just can't put it in the downtown Oakland area. Like, where do you actually site it? So a big part of replacing this power plant is creating flexibility in how these buildings consume energy so that we don't have to repower this plant, which we really can't do because of climate goals. We're also dealing broadly with electrification in California of transportation, but also heating, domestic hot water. And everybody thinks that's groovy. When we measure it, we're creating a 7 a.m. winter peaking grid. And so those of you that know about when the sun goes up and down, for example, this is perhaps the hardest time of the year to decarbonize. And so it's going to take kind of a whole suite of solutions to enable us to move off the natural gas grid onto electricity and then also decarbonize supply across the entire 24-hour period of the day. And again, all these heat pumps building a morning time winter peak, which is not the easiest time to decarbonize. So our solution, and really what the OpenEEmeter enables, which I'll get into, is how do we integrate these behind-the-meter flexible resources into this broader suite. We don't differentiate between efficiency, DR, storage, or EVs, or behavior programs, or smart thermostats. All of these things affect demand at the meter. And so what the OpenEEmeter measures is hourly demand change, and then we can further refine that into what is predictable and long-term, which looks like capacity, and what is responding to some sort of event, which looks like energy. Pay for it in the right market, value it correctly, but be agnostic to how you get there. We don't care. In fact, it's not that we don't care, it's we believe that most of these solutions comes in suites. They're not measure-based. So we clear trades for Sunrun, doing behind-the-meter solar and storage. When they get paid at the meter, they put in smart thermostats also, because it makes them money. Right? So how do we take a more cohesive kind of universal approach? So the big challenge in energy efficiency and really flexibility in general is what is, again, our product? And it has been a stack of reports that come in a PDF at the end of 5 years to date, and they all vary. So really that's the key thing that we're putting in place, the OpenEEmeter, is an agreement on that calculation. These are calculated values. You have to generate a counterfactual. Right? Once you change a building, there's no baseline. So what the OpenEEmeter combined with the CalTrack methods, which are part of the Linux Foundation, provide is a consensus set of methods that tell us how to go from raw AMI data. How do you clean the data? How do you find weather stations? How do you run the regression modeling on it? How do you generate the uncertainties and roll that all back up? And then the OpenEEmeter, which is the implementation of those standards, those methods. When you put those together, it's a weights and measures. Companies in the market that are getting paid can actually quantify their own impact and get the same answer as the utilities, the DTOs, the DSOs, the retailers that are paying them, depending on the value stack, and agree with the regulators, and you can do that in real time. So I just threw these in this morning, but this is what we're actually doing. I'm gonna make this really short. This is what the meter actually does. First, after cleaning the data, we bin for occupancy. So identifying state of the buildings that open or closed. Then for each building, we generate a monthly model of relationship of temperature and energy use for different states of temperature for the building. And then we use that and apply it in the performance period to predict a baseline. And you get something like this. These are examples of real results from a PG&E program. These are commercial assets predicted versus actual consumption in these buildings. The delta represents the change. And it's largely predictable. And then when we find we can't predict it, there's something large and unexpected happening that occurs. That's where we kind of break into engineering. But this is essentially what the meter does, is provides these baselines. And allows us to track projects and portfolios in real time, often updating nightly, and then can also be applied in the population. So you can actually target the right customers, track trends broadly. That's what the OpenEEmeter does fundamentally. It's that underlying calculation. And so it's really important if you have a contract that says you're going to get paid for performance, or you're a grid operator expecting a certain level of flexibility, and you're not buying more power, that you can track it and quantify it and know how good it is. And we generally run these on the whole population in advance, and we can quantify how good are these calculations at predicting baseline periods, and you get your uncertainties, and it starts to look and feel like an actual resource. So that's the objective. And then we use that, and we facilitate this, we don't create the market, is rather than focusing on the storage solution or what IoT thermostat you're installing, and they all perform differently, we want to break this apart. And we say, look, there's an awful lot of really interesting business models. There's not one solution. We wouldn't know it if we saw it. So we can make markets. And so instead of running efficiency schemes and programs that rebate in advance different measures and technologies, we have companies like PG&E, Con Ed, others up and down, mostly California, New York, Massachusetts, Oregon right now, that will pay aggregators who compete with each other for what they actually deliver over time, creating a cash flow, right? And financing that cash flow is infrastructure finance, right? And so rather than we can be totally agnostic to how we actually fix the building and focus on quantifying the impact and paying for the actual outcomes. So real quickly, this is the kind of stuff, I'm gonna bang through this really quickly, but this is an example of the kind of tracking we're doing with the OpenEEmeter. This is a residential program in California where we did HVAC work. This is when the savings are happening. Customers are saving 11%. Efficiency in a distribution is very, very reliable, and that's why it makes sense to grid operators. You get more projects like this, it'll fall into this distribution every single time. Well, somewhere in that distribution. And we can also take that hourly 8760 demand flexibility model and apply it to, for example, in this case, California's avoided cost on a marginal nodal hourly basis. So these customers generate about 0.4 tons of carbon per year per customer. By the way, if you're measuring carbon using monthly averages, you get the incorrect answer. It's not slightly off, it's not inaccurate, it can be just wrong. And we can also track against really all these, the capacity, energy, T&D, GHGs, what is the value, and again, on an avoided cost basis of each customer, which is about $150. And you can do things, but then you can do things like target, right? So like saying, well, okay, well, if we actually now care about producing results, not selling equipment, how do we make this better? So this is a targeting where we say like, well, we want to save energy in the summer, we want to save a lot of avoided costs in carbon with HVAC. Let's look for HVAC users in the peak periods. And when you do that, you get drastically different results. You increase the savings by the customer by 250%. We get 70% fewer negative numbers. And we drastically increase GHGs and avoided costs. So we're enabling utilities to figure out in their customer base, who are the customers that will actually benefit themselves and the grid with different interventions, and actually target them and identify the early adopters, and then enable and incentivize the market to go pursue those adopters because they care about delivering outcomes, because outcomes are what pay the bills. There's also a whole bunch of folks that we should not serve. This is 22% of all the population. There's over 1 million customers in PG&E territory that if you put in an HVAC system, don't save energy and have the bills go up. Maybe we shouldn't go give these people incentives. So pretty basic stuff, but it completely changes the game. And the economics of DERs, when you target potential, drastically change. And so we were able to provide this kind of feedback, typically updated nightly for both the aggregators and for the utility customers. Being used across a whole bunch of utilities and regulators and folks across the US. We work with the regulators, we often work with the utilities at the same time, and then we also provide tools for aggregators because there's a standard, we provide essentially the OpenEEmeter as a company that's our business is providing it on a SaaS basis. It is open source though, that's part of the importance here is that you can't create a market in a black box, you can't bet it, so folks can use the OpenEEmeter to calculate their own savings. Our business is doing that at scale. And so these are just some examples of the customers who are using the OpenEEmeter. So we think while it's new to LF Energy, it's been open source for about 4 years, since 5 years actually, and we're getting a lot of actual adoption across different countries, mostly in the US. We hope to actually have it here in Europe sometime soon. So that's what the OpenEEmeter project is and what it's for. Thank you.